Hello guys and welcome back to class. We are going to be having a double integration here to do, and I'm going to show you how to do this. You have to take you have to do one after the other. So in this situation we have evaluate. Okay, we'll have this, you have the integral from 0 to 1, and you have an integral from 0 to x. You have x squared plus y squared, or dA, where a indicates small area in xy. Now, whenever you have dA, this is changing a, it's talking about a differentiation of area, or rather an integration. Sometimes it can be to get the area of a small size of a strip, just the size of a strip. Now, for that now, what we're going to do is, first of all, we're going to take the dA that we have here that's given to us. dA, we're going to be representing it with changing y and changing x. Why I'm putting changing y and changing x is because I will have to integrate with respect to y first of all, then I will now integrate with respect to x. So bringing it down, I'll have my integral from 0 to 1. I'll have the integral from 0 to x squared plus y squared. Then this is going to be my change in y, then my change in x. So remember, as I said, we are going to first of all solve with respect, or integrate with respect to my y, then I'll integrate with respect to my x. So integrating this now with respect to y, each of this term, I'm going to integrate each of them with respect to y. I'm going to have so let me say, I would say let I equal to this. Let I equal to that. I'm going to have the integral from 0 to 1. For this now, I'm going to have something like this. Integrating this, if I integrate x squared, I'm going to have xy, x squared y. Okay, let me make it bold. I'm going to have x squared y, because remember I'm integrating with respect to y. Then for the second one here, integrating this now with respect to y, I'm going to have y cubed all to power 3. Then I'm going to have the interval 0 to x. So I'm putting 0 to x, changing x. I want you to note carefully that I did not put this integration symbol at this point. You know, this first integration symbol, look at it here. So when I integrated, I didn't put this symbol any longer. I just took the interval and I put it at this end. And look at the kind of bracket I use. I can use these brackets. I can decide not to use this bracket. I'll just give a straight line, put it on it like that. I can use parentheses and then put a straight line at the end and put the interval. The major thing is that your interval has to be shown. The interval has to be shown. So if I impute my interval now from this to this, look at this carefully. You know that imputing intervals, what it means is that I would carry this, my x now, put into this expression here. Wherever I see y, I'm going to put x there, because I integrated with respect to y first of all. So it is y that I'm going to be replacing. So I'm going to take this higher interval, I'll put it, then subtract the lower interval from it. Now, if you look carefully, if I should bring this lower interval into this place, if I put 0 here, here will become 0 times x squared, which is 0. Here will become 0 divided by 3, which is 0. So imputing this 0 interval will make everything to become 0. So that part is gone. It is left with this. So imputing this x interval, the higher interval here, into this, I'm going to have x squared times, put x here. So it's going to be x cubed plus this place now is going to be what? Okay, it's going to be x cubed over 3. Then changing x. You see that? The x. So my y here is replaced by my x, like I said earlier. Now this final point now, I am now going to integrate with respect to x now. That's why you have to do double integration to integrate with respect to x. So integrating this now, I'm not going to put this sign any longer because I'm now integrating. So this is going to be x to the power 4 over 4 plus x to the power 4 over 4 times 3. Now I can do it like this. Put a straight line here, then put 1 and this. You see, like I was saying, I did it this form with a square bracket. I have my 0 and my this here. Now I'm using a parenthesis. You see that after my parenthesis, I have this. My interval must show. Do you get that? Now, like we did at first for this one, wherever I see y, I'll put x, which is what I have here. And wherever I see y for the next point, I'll put 0. And when we added 0, everything here becomes 0. So I'll check, is it still possible here? If I put the interval 0 here, this point is 0 over 4, which is 0. If I put the interval 0 here, here is 0 over 4, which is still 0. So it is only the interval 1 that is going to be valid here. So if 1 is going to be valid here, then I'm just going to put it here. I'm going to have 1 over 4 plus 1 over 12. Do you see that? 1 over 4. Then is addition. I'm just going to look for the LCM. So 4 comes here, gives me 3 plus this is going to give me 1. So I'm going to have 4 over 12. And if I evaluate that, I'm going to have 1 over 3 square unit. You see? So it's an area. We're looking for the area. That's why I'm using square unit. So try this out. Let me see. You have something like this. You have the same interval. Let me put 0 to 1. And the second interval is 1 to x. I'll just give you a simple question that you'll be able to answer quickly. So like this. So try this one out and let me see what you are going to get. That if you don't understand, you can ask a question in the comment section. Please, I wanted to share this video. Like the video also and also comment. And if you don't understand anything, you can ask a question in the comment section and I'll do it to answer you. And until then, I'll see you in the next class. Bye.